Anyway, so let us start now. So as you guys can see, this is 23 slides only. So I hope we can finish this one in just 30 minutes. Okay, since this one is super easy. So the last module before your midterm exam is problem solving. So here are the list of topics that we are going to discuss. So inductive reasoning, counterexample, and then deductive reasoning. So before we start, anyone here who has an idea what is inductive and deductive reasoning? Anyone who've heard about inductive and deductive reasoning? None? Is this your first time, guys? Okay. So one thing is for sure, whether you are conscious or not, we always use this one. Okay. So in our daily lives, we have
Isa
this
na pala.
inductive reasoning, and then we have this deductive reasoning. So in this module, we'll be able to distinguish what is this inductive and then what is this deductive reasoning, or what are their differences with each other. And then counterexample, I think it's very obvious. Like we're going to find a example to make the statement false. Okay, that's why it's called counterexample. Anyway, let's start with inductive reasoning first. So when you say inductive reasoning, it is a type of reasoning that forms a conclusion based on the examination of specific examples. Is called inductive reasoning. So in our daily lives, whether well, we know that it's inductive reasoning or deductive reasoning. So we always form a conclusion in our mind. Okay, like we are saying that, okay, so the next one who will win will be maybe the Lakers, okay, or the Clippers, or the Golden State, okay. So we are basing that one from the past, let's say, game that they had. So we are basing that one on the performance of maybe of that player. They have this new player now. This team now is super strong. Okay, something like that. Okay, so the same in other games, like assuming that this one is a genius man. Because of him, this team will win for sure. Okay, you are now forming a conclusion based on what you are seeing, okay, or based on the example that you are seeing. So we call that one inductive reasoning. So the conclusion is formed by using inductive reasoning is the conjecture, since it may or may not be correct. So in here, it's just that there is no guarantee. So that's why it's called conjecture. So we could see that inductive reasoning is the first judgment, wherein it's just our instinct. Okay, that's what is trying to say with our, with the first look on that one, or in that situation, or with the first glance. Okay, so yeah, it, it's 50-50. So it may be you are maybe correct, or you are maybe not correct. So inductive reasoning is a process of reaching a general conclusion by examining specific examples. So when you examine a list of numbers and predict the next number in the list according to some pattern you have observed, you are using inductive reasoning. So to make it short, when we say inductive reasoning, you have a basis, and then what is that basis? So those are the examples. Okay, so let's have an example. So use inductive reasoning to predict the next number in each of the following lists. So number one, we have 3, 6, 9, 12, 15. So what is the next one?
18.
Yeah, of course, most of you will answer 18. So it's a natural pattern already. So without realizing, so the next number that you will say is 18. Okay, so the same with 2, 4, 6, 8, 10, 12. So it's like counting even numbers. So the same with this one. It's like counting call this one. Di naman siya add, di naman siya even. But yeah, counting with an additional 3 on every next number. So the next one is 18, of course. So yeah, you're basing that one on the past examples. How about number 2? We have 1, 3, 6, 10, 15.
21.
Mm-hmm. So what about the others? You guys have the same answer?
21 din sa.
Okay, so this one is quite harder. So at first glance, maybe wasn't able to get this one, but maybe after 10 to 15 seconds, you realize that the first difference is 2, the second difference is 3, the third difference is 4, and then the last difference, okay, of those two sequence is 5, then the next one should be 6. So that is why we have 15 plus 6 is equal to 21. Okay, so again, how did we get that 21? Because we base it from these past examples. So in here, we cannot just get that one if we only have two preceding examples. So we need as much as we can, and then that pattern must not must not be broken, or must be all throughout from the start back to the end. Okay, because if at the middle, let's say you have 2 right here, and then at the middle we have let's say 5. Okay, like 6 plus 10 is 11. Then your assumption now is incorrect, which will ruin your prediction. But in here, everything is smooth from the start to the end. Then you can apply inductive reasoning. All right, so here are the solutions. So again, I will leave the reading part to you guys, but yeah, the correct answer is 18, and then the next one, or the number 2, is 21. Okay, so let's have another example. So use inductive reasoning to make a conjecture. So consider the following procedure: pick a number, multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract by 3. Okay, so anyone who would like to suggest a number? Sasser, pick a number. So any number will do.
7.
7. Okay. So let's use a notepad. So we have 7 as our original number. And then the next one, we have to multiply that one by 8. 7 times 8 is how many? 7, 14, 21, 28, 35, 42. Is it 42? 14, 21, 28, 35, 42. No, 49. Okay. And then add 6 to the product. 49 plus 6. Oops. 49 plus 6 is equal to 55.
Sir, 7 times 8 is 56.
Sir, 56. 7
56.
times 8.
Ano isa? 56. And this one will become 56. And this now will become 62. And divide the sum by 2. So 62 divided by, where is our division? This is equal to 31. And subtract by 3. 31 minus 3 is equal to 28. Okay. So other number. Let's have another number. So it has to complete above procedure for several different numbers. So let's have another one. Anyone who would like to suggest a number again?
5, sir.
5. Okay, so 5 times 8 is equal to 40. And 40 plus 6. Easier if I will just copy this one. And just 1 to 5 times 8 is 40. And then 40 plus 6 is 46. And 46 divided by 2 is 23. And 23 minus 3 is 20. Okay, let's have another one. Last one.
10.
6.
So, nauna yata yung 10. Okay, let's choose 10. 10 times 8. And let me just copy this one. So, we have 10 times 8 is 80. 80 plus 6 is 86. And then 86 divided by 2 is 43. And 43 minus 3 is 40. So in here, I think 3 examples, or yeah, 3 sequence is already enough. So if we have 7 as our original number, okay, this one will give us a result of 28. And the second one, if we have 5, this will give us a result of 20. And for the last one, we have 10. So if we have 10, this will give us a result of 40. Now, okay, I have a question, a real quick question. What if my number is 9?
36.
Okay, that would be 36. Do you guys have another uh, answer or assumption or conjecture? Or do you guys have the same? So I didn't know who answered
36.
36. But yeah, so just basing it from our past examples, if we have this kind of, a procedure, you can pick any number, but you will apply the same, step by step, like multiply it, add it, and divide, and then subtract. It will be always multiplied by 4, okay, from its original number. So 7 times 4 is 28, 5 times 4 is 20, 10 times 4 is 40, and then if we have 9, then that's equal to 36. If we have 8, then this one is equal to uh, times 5. Bakit parang may mali? Yeah, tama. And this one will become 32. 16 million for 32. Tik ko ng i-times 10 tuloy. Yeah, so in here, it's always multiplied to 4. Okay, so here is the solution. So if we have 5, we have equal to 20. If we have 6, we have equal to 24. If we have 10, we have 40. If we have 100, then we'll have 400. So in each of these cases, the resulting number is 4 times the real number. So we conjecture that the following the given procedure produces a number that is 4 times the original number. So again, this is an example of a inductive reasoning, since we base it, okay, on the data that we gathered, okay, or the data that we have. All right, so let's have another example. So it says here, scientists often use inductive reasoning. For instance, Galileo Galilei. So this is his birth date, and then the year that he died. So he used inductive reasoning to discover that the time required for a pendulum to complete one swing, called the period of pendulum, depends on the length of the pendulum. Okay, so Galileo Galilei did not have a clock, so he measured the periods of pendulum in heartbeats. Okay, so the following table shows some results obtained for pendulums of various lengths. So for the sake of convenience, a length of 10 inches has been designated as 1 unit. So in here, if we have 10 inches, so that's already considered as a 1 unit. So a 10 inches length of pendulum will give us 1 heartbeat to complete one swing. And when we say one swing, okay, it takes, where is that one? Okay, so here. So in order for us to see that it's already one swing, okay, so from its real position and then swinging to the right, and then it must go back to its original position. So that's why it's called pendulum, okay. And then Galileo Galilei measured that it will only take 1 heartbeat, okay, before it will go back to its original position. So in here, 10 units, I mean 10 inches or 1 unit is equal to 1 heartbeat. If we have 4 units, we have 2 heartbeats. If we have 9, we have 3. If we have 16, we have 4. If we have 25, we have 5. If we have 36, we have 6. Okay, so what did you guys realize, okay, regarding with this graph right here? What if we have a heartbeats of 7? So what is the length that we should have in here?
49.
49.
Yeah, 49. So it's like always the square root, okay, of the length of the pendulum, okay, which is equal to the heartbeats that you will have in here. So, sagutan na natin yung sagot. I mean yung question. Anyway, so here are the questions. Supposedly, if a pendulum has a length of 49 units, so what is its period? So the answer is 7. If the length of a pendulum is quadrupled, so let's just answer number 2. What happens to its period?
Sir, it is doubled.
Okay. What about the others? You guys have another answers? So according from Mr. Esguera, the heartbeats were doubled.
I agree, it's double.
Yeah, agree also. Okay. Okay, so I was actually looking for another question, but yeah, I don't know how to ask that one. But yeah, if it's quadrupled, your heartbeat will double. So if you are going to take a look on this one also, so the four were being quadrupled, so the heartbeat will also double. Okay, but how do you say this one? Because five is like quintupled. Nine is, I don't know, but it's nine times, okay, of the pendulum, but you will get three heartbeats. So if you are going to multiply this one by four again, wherein it'll give us 36, so this one is also double. Okay, so hindi ko lang alam paano sabihin yung 9 nanocoupled. I don't know. So yeah, it's like 9 times. Anyway, so here is the solution. So here are the explanations for the number one and then for the number two. Okay, so quadrupling the length of a pendulum doubles its period. Okay, so let's answer this one. So consider the following figures and the pattern suggested. So here are the number of points connected, and then here are the number of regions formed. So if we have 2 points, okay, so this is the first point, and then the second point. So as a result, it gives us two regions, 1 and 2. If we have 3 points, so 1, 2, and 3, so just connect all of those points in to give us a number of 4 regions. So 4 points is 8 regions, 5 points is 16 regions, but what about 6? So I will maybe give you guys 2 minutes or maybe 1 minute. 1 minute is enough, I guess.
32.
32. What about the others? So with this kind of example, we always use inductive reasoning because we hate to do hassle things. We hate to do this kind of things. We don't want to waste time, but instead we'll find a way to predict what will be the next number or how many regions will be formed if we have 6 number of points connected to each other. So all of you has an answer of 32. That is your conjecture. Okay, so let's see what is the real answer. So in here, the correct answer is actually 31. Okay, not 32. Okay, not as you may have guessed. Okay, so just because a pattern holds a true for a few cases, it does not mean the pattern will continue. Okay, so there are some cases. So actually, there's a lot of cases like this wherein, yeah, it holds for 5, 6, 7, correct sequences, but at exactly or the next of that one, it's not correct anymore. Okay, so when you use inductive reasoning, you have no guarantee that your conclusion is correct. So it's always 50-50, even though you base it right here and then your solution is correct. Your way up or your approach is, let's say, correct, it's still not guaranteed. Okay, so in here, there is no guarantee. So here is the actual, okay, counts of regions if we have a total of 6 connected dots. So up to 31 only. Okay, so you might want to try this one also. Anyway, so the one that we have here, okay, at this point, okay, since it's the first one, second, third, fourth, and fifth, the fifth term is called the counter example. Okay, so yes, it is true for the first fourth term, but at the fifth term, it is already a counterexample since it made the pattern incorrect already. Okay, so there is no such pattern anymore since at that point it's not true anymore. So a statement is a true statement provided that it is true in all cases. But if there is one, if you can find one case for which a statement is not true, it is called a counterexample. Okay. Then the statement is a false statement. In the next example, we verify that each statement is a false statement by finding a counterexample for each. Okay, so let's find a counterexample with these numbers. So verify that each of the following statements is a false statement by finding a counterexample. So for all number x, so I would like you guys to find at least one counterexample. So there's a lot of counterexamples out there, but one is enough already. Just make this one false. 1.0, 1 is actually greater than 0. That's actually true. Zero point one is 0. Ay, parang may mali. Okay, so because I just updated this one a while ago. Negative. No. This one is correct. So can you guys find a counterexample for the number 1?
Negative 1. Negative 1.
Negative 1 is greater than 0. I mean, yeah, negative 1 is definitely below 0, but we have an absolute symbol right here.
1.
So
Okay.
it will become
Absolute pa. No sign.
So yeah, but this one is super obvious. It seems like there's something wrong with number 1. Well, you can just answer here any decimal that is less than 1. So 0 0.5, 0 0.9. No. Because 0.
That'd be greater than 0.
Yeah. Okay, I don't want to, go to the other slide because it will show the answers for number 2 and number 3 also. Anyway, so anyone who can find the counter example of number 1. Can't remember what is the correct answer for this one. Ano ba yung ginawa ko dito? Parang may nabura akong hindi dapat. Anyway. Anyone?
0, sir.
Yeah, just remember, 0 is actually correct answer. So thank you for that one, Mr. Gio, Miss Rihanna, and Mr. Christian also. Okay, so kanina ka pa pala may sagot eh. Why are you not speaking, Mr. Christian? Tinype mo pa. So the
I was
correct
eating
answer
an apple.
Okay, the answer number 1 is 0. So 0 is not greater than 0. Okay, how about number 2? Just find one counterexample.
1, sir.
Yeah, that's correct. So 1 squared is 1, but 1 is not greater than 1. Okay, what about number 3? Okay, very good, Miss Rihanna. Miss Rihanna Aliana. Wow, what a beautiful name. Okay, so negative 3 raised to 2 is, of course, positive 9. But yeah, and square that 1, it will become, wait. Yeah, it will become positive, but the right side x is still negative. Okay, so positive 3 is not equal to negative 3. So the correct answer is negative 3. So I think negative 1 is also correct. So there's a lot of counter examples out there. You just find one. So here are some of the answers. So of course, this one is false since if x is 0, so this one is not true all the time. So the same with number 2. So just by answering 1 or 0, now our x right here. So This is not true all the time anymore. So for the number 3, so we have -3. Okay, okay, let's oops. Okay, so here are their explanations. Yeah, so just read them. Okay, so let's now proceed to deductive reasoning. So the main difference of inductive versus deductive reasoning. So even though you don't have, or you don't have any data, okay, so as long as you have these principles or procedures which is already, approved by everybody, by everyone, or most of the people around the earth, I guess, since that's like, a common phenomenon already. So you will be able to get the correct answer. Okay, so it will only be 100% correct if you are going to use a deductive reasoning. Okay, so there still might be a loophole, like this will it's not 100% guaranteed, but this one is much more better than, just by applying inductive reasoning. So in here, this is another type of reasoning, is called deductive reasoning. Deductive reasoning is distinguished from inductive reasoning in that it is the process of reaching a conclusion by applying general principles and procedures. So deductive reasoning is a process of reaching a conclusion by, again, applying general assumptions. Okay, so this one is actually kind of the same. So we forgot to highlight this general. So this one is part with these assumptions. So this one is kind of the same with inductive reasoning. That's why it's being distinguished from inductive reasoning. Though we have an additional one. We have these procedures or principles. So yes, we still, if you are applying deductive reasoning, you're still applying uh, inductive reasoning. Okay, so you're still relying on the logic behind that one. But yeah, we have to apply more, which is maybe the procedures or the principles. So later on, you will see uh, the process, or what are the differences. So let's use the same example. So we use deductive reasoning to establish a conjecture. So we use deductive reasoning to show that the following procedure produces a number that is 4 times the original number. So in here, we are going to prove that the one that we had a while ago is actually true using a deductive reasoning. So here are the procedures. So pick a number, multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract by 3. So in here, we are going to replace the original number by n, so that, any n, okay, we can easily just apply whatever is the formula that will be formed, okay, and then just use that formula, and then we'll have the correct answer as soon as possible. Okay, so we don't need to use a lot of examples. You don't need to have a lot of data in here. As long as you have this general, uh, you know, say formula, okay, not general formula, but just formula, okay, which is equal to 4n. So in here, 8 times n, and then 8 plus 6, so just add 6, and then divide that 1 by 2. Okay, and then if you're going to simplify this one, it will give us 4n plus 3. And then 4n plus 3 minus 3 is equal to 4n. So as a result, this is now the one that we can use, okay, which is already proven, and then it's already being call this one, let's say, approved by everybody, because that's how we've come up with such a formula with this procedure. So we started with n and ended with 4n. So the procedure given in this example produces a number that is 4 times the original number. Okay, so if you only know how to manipulate, or how to use maybe variables, so it would make your work a lot easier, okay, rather than basing that one on a real data. So before, we have to compute 3, 4, or 5, and then just compare those sequences, and then before we can figure out what would be the result if we have this kind of number. But in here, just substitute that original number to our n, and then you will get the correct answer, right? Okay, so let's have another example wherein in these examples, it will let us analyze arguments to determine whether they use inductive or deductive reasoning. Right, so sorry with that. Let's just read by the others. Again, I thought we can finish the entire you know presentation in just 30 minutes, but I think I need more time to finish this one. So yeah, two slides remaining left. Well, actually one slide remaining left. The last one is end the presentation. So let's just read by the others. How many are we in part one? Can anyone remember or have
26.
26? So there were three more. Well, this one is recorded anyway, so if may umalis pa. So just in case that they won't be able, they won't be able to join us anymore, then we can just they can just watch the recorded video. Okay, so let's finish this one now. So again, number one, during the past 10 years, the tree has produced plums every other year. Last year, the tree did not produce plums. So this year, the tree will produce plums. So is this inductive or deductive reasoning?
Inductive. Oh, yeah.
What about the others? Who says here deductive reasoning? Okay, so none. So most of you has an answer of inductive reasoning. So the correct answer is yes, inductive reasoning. So this one is inductive. Why? Because we have this data, like for 10 years, uh, we have this alternating, okay, wherein for this year it will produce, after that one it will produce plums, and then will produce again, and then it's just alternating, like that is already the pattern, or that is already the data that we have. Okay, so we base our next prediction regarding on that one. But what about number two? All home improvements cost more than the estimate. The contractor estimated that my home improvement will cost $35,000. Thus, my home improvement will cost more than $35,000. Is this inductive or deductive?
And deductive meaning.
Deductive, coming from Mr. Bukang. What about the others? Do you guys have the same answer?
Was the constructor estimated at minimum 35,000?
I mean, this one? Contractor
Because
estimate.
the second sentence says it will cost more than 35,000. I don't know if the estimation is like the average 35,000 or would be more. The minimum is 35,000.
Let's just say this one. Okay, so I don't know how did they compute this one, but according from the contractor, and then we don't know what is the structure of that customer wants to be, improved more or to be more renovated. So he just calculated that it would cost that owner $35,000. But yeah, according to other maybe homeowners, all home improvements cost more than the estimate of the contractor. So would be, this one more than $35,000.
Sir, para sa akin, inductive.
Okay, why?
Kasi sir, estimate according sa kanya, and sabi niya rin na yung mga ibang house cost more than, so parang nag-ano siya ng pattern na after years siguro ganito na yung cost ng home mo or something. Ganun, sir.
Mhm, mhm. Well, that's a good answer, though. You're missing one thing in there. What about the others? Most of you have answered deductive.
Inductive.
Correct answer number 2 is actually deductive. Okay, why? Well, yes, it's true that we have this data, like all home improvements cost more than the estimate. Like we could say there's thousands of homes out there, and then we could say we could use that data as our basis, and then we could just assume that yes, it's inductive. Though when we say inductive, we must have a real data. Okay, we must be saying a real computation. Okay, but in here we're using or we're applying the principles, okay, or the general assumptions. So yes, the one that you're talking, I don't know who is that one. It's actually the general assumption. Well, if we only have general assumptions, so that is true. Okay, it's inductive reasoning already. But then again, we must apply these procedures. So what is that procedure? Okay, and then what is that principle? So that principle and then procedure is this one. Okay, this idea right here. Okay, so the principle that all home improvements cost more than the estimate. Okay, which came from another household. So here are their answers. So this one is inductive reasoning because we base it from specific examples. And then number 2 is a deductive reasoning because we have a general assumption. Okay, so if this one is a real data, okay, if we have a real data, maybe 5 households or 10 households, maybe you could say that it's inductive reasoning. But since it's one only, like one principle only, okay, or one assumption, then that is deductive reasoning. Okay, so with that, since like there's still a lot of things that you need to learn when it comes to inductive and deductive reasoning, I would like you guys to search more on the internet, like more examples. So in here, you've just learned the the idea on how to detect if it's inductive or deductive reasoning. So in order to enhance more your uh, maybe your assumption with that one, okay, so you can maybe visit one of the links that I right here, one of the links that I did include in here. So you can check these quizzes. So just to review inductive and deductive reasoning. Okay. And then again, don't forget that you guys have 6 quizzes plus one discussion. So the due date of this one will be on September 16th. Okay. And then one more thing, let's have a votation right now. Okay. So I think it would be better if we're going to finalize everything now. So would you guys like to have a discussion next meeting? But of course, we're going to have an advanced discussion for the finals, right? Which talks about logic puzzle. But if not, it's okay. We'll just discuss this one after your midterm exam. So to those who would like to have a discussion next week, would be September 13th, Monday. Okay, so just give me a thumbs up, and then of course majority wins. So 5, 4, 3, 2, 1, and then 0. So 2, 4, 6, 8, 9. I think that is not enough because there were, let's see, 28 of you guys less me. So I need at least maybe 15 or 14, but 9 is not enough. So yeah, you guys are going to have a free time. Well, not actually free time since there are things that you guys need to finish or you need to do. So yeah, September 13 and September, ano ba ngayon? Di ba man-liters dito? Yeah. So dalawa yung free time. And then your midterm exam will be on September 20. Okay. So we will not meet next week. Okay, Monday and Thursday. So use that time to finish all of the activities that your other instructors gave you. Okay, so in my case, ito lang naman. Sobrang dali lang. And then, of course, needless to say, the coverage of your midterm exam will be all of the modules. Okay, those 3 modules. Okay. So, any concerns so far or clarification?
No, sir.
Ako, sir. Ako, sir.
Okay. What is your concern?
Yung dun sa ano, counter example, sir.
Mhm.
Medyo magulo lang sa akin.
In what way? This one?
Like, paano nakuha yung number na substitute dito sa X?
We are the one. Let's just assume that X is a real number, like any number that you can think of. Okay. So yeah, just make this statement false. And then that number is already a counter example. Okay, so we have 2, 3, 4, 5 counter examples in that number. But just one counter example, that's already enough. Okay, like for example, this one, I think the only counter example that you can think for the number 1 is 0. So there are no other numbers that will make this statement false. Other than that, it's true now. Okay. So, was I able
So,
to?
parang ano, sir, kailangan yung statement magiging false
Yes.
para masabi natin counter example.
Yes. Yes.
Thank you po.
Okay, you're welcome. What about the others? Any other concerns or clarifications? Hmm,
Sir, paano yung exam?
if I'm not mistaken, I think lahat yata yun, multiple choice yung ginawa ko.
Isa canvas din po bibigay?
Yes, kind of as
Oo.
everything
Okay.
is
Okay po.
of course, you'll be given a limited time only. So, hindi ko alam kung ilan yung nilagay ko. I think it's 2 hours only. Or if you guys are lucky, I gave the entire 4 hours. So, imagine that. That's actually quite unfair. So, yung gamit kong exam ngayon, yun pa rin yung exam dati, wherein we only have 1 hour and 15 minutes. Then we have to finish those, let's say 100 points, hindi naman 100 items. Pero 1 hour, 15 minutes lang, and then say, papasok pa kami, ibibigay po yung test paper. So let's just say that we still have 1 hour and 10 minutes or exactly 1 hour. Kasi before 5 minutes of the class, pinapasubmit na ng instructor kasi may susunod na sa klase na room na yun. So unlike now, I just really hope that you guys are, not cheating. Kasi kayo yung kawawa. Actually, naawa nga ako sa inyo eh. Sa generation nyo ngayon. Kasi kung dinadayan nyo lang yung sarili nyo, and then, kayo din yung kawawa kapag graduate kayo. Wala kayong natutunan. Okay, so I just really hope that, whatever you can get on that exam or quiz, then so be it. And then just ask me, sir, why did I get 0 on this activity? So, sir, why did I only get half of this one? Okay. So, yeah, marami naman tayong free time, or you can just message me. And willing naman akong sumagot. Okay. Kapag nakita ko yung question. Well, anyway, So, yeah, alam nyo na yun. So, hindi na dapat sinasabing no cheating. So, tulungan, okay pa siguro. Basta naintindihan nyo siguro. So, ang sa amin lang, basta matuto na lang kayo. Hindi yung stricto pa, tapos wala namang kayo natututunan. Then, it's nonsense. So, yeah, tulungan na lang. Wag kopyahan. Okay? Well, anyway, so any other concerns? Okay then. So if you guys don't have a question anymore, then meeting adjourned. So let's just meet again after your midterm exam. So goodbye and thank you guys for coming.
Thank you,
Bye,
sir.
sir.
Bye.
Bye,
Bye,
sir.
sir. Thank you po.
Thank you, sir.
Bye, sir.
Bye, sir.
Thank you, sir.
Bye,
sir.
Goodbye.
Po.
Bye po.
Goodbye po.
Goodbye, everybody. Goodbye.
Goodbye, sir.
Goodbye.